All right, so the largest one-dimensional object we have is a line, correct? Which has how much length? Infinite length. Well, a segment is this. A segment is part of a line with two endpoints. A segment is part of a line with two endpoints. And let's just sketch one in here in the spot where it says example. But can you see how I didn't put any arrows on that puppy whatsoever? I did not put any arrows on there. My question to you is, how many dimensions is a segment? Is it 0 dimensions, 1 dimension, 2 dimensions, 3 dimensions? How many dimensions does a segment have? One. What is that dimension? Length. But it has an actual length. It does not have infinite length. Can't we put a ruler on top of this and figure out exactly like how long that thing is? Right? How to name a segment, though? This is called segment AB. Right? So you need the A and the B next to each other. And we got to have a symbol above it. But take a wild guess what the symbol looks like. It wouldn't look like a line, because that means line AB, right? And how many arrows should it put on it? That's my question. None. That's it. You don't need the dots. And I heard a lot of you calling that line segment. It is called a line segment. Cut off the word line and just call it a segment. Sound okay? This says segment AB. Could I call it segment BA? Yes. Now let's say there was a third guy on there just for fun, C. But I want to talk about the green thing. Does this represent the green thing right there, this segment AC? Does that represent the green thing? No, a segment must be named by its endpoints. Isn't A the end of the green one and B the end of the green one, right? Segment must be named by its endpoints. That sound okay to you? So, segment. So then let's talk about the word between. On line PQ, to say that point M is between points P and Q means that P, Q, and M are collinear. Holy cow, I'm giving you a vocab word in the word between. And in that vocab word, it has another vocab word of collinear. Can you kind of see why we need vocab tests in here? Because we'll have a vocab word inside of a vocab word. What does collinear mean in the first place? On the same line. Between mathematically means something different than between in real life. So between mathematically, they have to be collinear. Points P, points Q, and point M. Is point M between point P and point Q? It's not. Why not? They're not collinear. Now it's like, but it's like between this. You know, there's a difference between realistic between and mathematical between. So no dice. Is point M between point P and point Q now? So mathematically between, they have to be on the same line to be there in the first place. Okay? And you can see that in this picture. Isn't point M between point P and point Q right here? Sound cool? Have you ever heard of the word congruent before? If you have not, that is fine. Congruent means that things, in our own words, same size, same shape. Same size, same shape. Okay? Things that are congruent, let's put that off to the side because the word congruent will not go away. It means that they are the same size, same shape. Same size, same shape. So we need to learn to read some other stuff right here. Whoa, my friends. You see that right there? That's a capital A right next to a capital B. Is there a symbol above it, like a line bar or a segment bar or anything like that? So this means the distance from. The distance from A to B. Isn't A a point because it's a capital letter, and B is a point because it's a capital letter? This says the distance from A to B is equal to the distance from B to C, which equals 3 centimeters. So let's put that in our picture over here. There's our picture to the right. What's the distance from A to B? So let's put that right here, 3 centimeters. Distance from B to C is 3 centimeters. Those are equal to each other. Is that cool? So this segment, I'll just call them in colors now. The green segment and the red segment, aren't they the same length? That's what this is all about. When there's capital letters with no bars above them, that's their distance, a.k.a. their length. Cool? Well, are these the same size? And are they the same shape? First of all, they're the same shape. Aren't they both segments? Right? Are they the same size? This is 3 centimeters long. That's 3 centimeters long. Well, they're congruent to each other is what that means. And now we'd say this. Segment AB is congruent to segment BC, which is written right there. But here's the big thing. Symbolization is crazy. Do you see that I had segment bars above this information right here? And this is the congruent symbol. It's an equal sign with a little squiggle above it. If you use segment bars, you must use a congruent symbol. If you write this, this is wrong. Segment AB cannot be equal to segment BC. It just can't happen. Distances are equal, segments are congruent. Do you see how this is distances right here? I want you to write that where you got room over here. This phrase, distances are equal, segments are congruent. Distances are equal, segments are congruent. Distances are equal, segments are congruent. And you will find that I will be marking a lot of stuff wrong on your homework quizzes, and I will be checking stuff on your homework, and I will point out things, that's wrong, that's wrong, that's wrong, that's wrong, that's wrong, all because you have the wrong symbolization. What if I wrote this? Is that right or is that wrong? I don't even see a picture. I don't know what this A is, this B, this C, but that is totally wrong. Because what does this mean out loud? If he was to read that, how does he say that out loud? Distance. And what symbol did I use? You can't do that. You can't mix congruent symbols with distances. So what about that? Would that be okay? Those segments can be the same size, same shape. But their distances of 3 and 3, those are what's equal to each other. 3 equals 3. The two segments are the same size, same shape. So, we cool with that? How do you know that they're the same in the picture, though? How do you know the same in the picture? We don't want to put the 3 in the 3 every time. You see these little tick marks on there. Tick marks mean that segments are congruent to each other. Marking our pictures is going to be very important. So tick marks on the figure indicate which segments are congruent. That right there tells me that segment AB is congruent to segment BC. Cool? And if they're congruent, that means that their lengths are the same. Rock and roll? So, they want us to do this on this first one. Wonder what that says. If you was to read it to yourself without any instruction, you would say, find EF. But that's not what that says. What does that say? Find the distance from E to F. Well, aren't those collinear points right there? All this? Here's E, here's F. If this is 1.2 centimeters, and this is 1.9 centimeters, take a wild guess of what we could do to find the distance from E to F. And what's the distance from E to F? Add them up. How much? 3.1 what? I'm big on labels. And that's not good enough, because I want you to get the symbolization right. I want you to write the distance from E to F equals 3.1 centimeters. But I sure as heck don't want to write a sentence. Mathematicians don't want to write a sentence. How can I simply write the distance from E to F real quick? Capital E, capital F. The distance from E to F equals, how could I write that? Equal sign. And you've been taught that letters next to each other means multiply them together. Well, that's if they're lowercase. If they're capital, that means that we have a distance. Sound all right? Cool. Now let's get nuts. First of all, what are they asking us to do? Find x and what? So we got two things to find, x and the distance from A to C. They got variables all over the place. Tell me in colors. I got a green thing, I got a blue thing, and I got a red thing. Correct? In colors. What has to be true about the green, the blue, and the red? Real simple. Green plus blue equals red. Doesn't that make sense? Green plus blue equals red. See how highlighters help me out? I'm a highlighter guy. What's the green thing in terms of x? How long is the green thing in terms of x? I made it, it's so easy that it's x units long, right? How long is the blue thing in terms of x? It's 2x. So wouldn't you tell me that green plus blue should equal how much? 2x plus 5. Didn't you tell me that green plus blue equals red? Set up that equation. Let's go. This isn't do stuff in your head, right? We're setting up an equation. They ask us to solve for x. So let's do that. Is that cool with you? I got x's everywhere. I got x's on the same side. I got x's on different sides. Can you tell me what you do with these x's over here on the same side of the equal sign? Combine like terms. That's 3x, correct? And that would equal 2x plus 5. So far, so good? Solve for x. And hopefully you get x equals 5. Do you get that? Let's see if we've answered the question. Find x and the distance from A to C. Have we done all that? We found x. Now let's find the distance from A to C. Isn't that the entire red thing right there? So distance from A to C will equal, I bet you we can do this all mentally. Don't we need to take 5 and put it in the place of x using the substitution property? 2 times 5 is? Add 5 more to it is? Is there a label involved? They don't tell us, so we'll put units. UN. If they don't give us a label, we will put units each time. 15 units. We're pretty comfortable on that. Q. Got that taken care of. Now, that was distance on a number line. Ooh, who knows what these things are? Absolute value. They are not the tick marks, I understand, but the tick marks are on the graph. These guys are absolute value bars. It's about distance. Do you know what absolute value really means you should do? Make it positive. That's a grouping symbol. You make the result of it positive. Let's talk about distance. Here's a real simple real-world problem. If I drive from Hayes to Salina, that distance is 90 miles. Sound all right? Now, what happens when I drive from Salina back to Hayes? Should that distance be negative 90 miles because I went the other way? There's no such thing. Distance has to be what? Positive. So if you're going from point A to point B on the number line, shouldn't that be the same distance as going from point B to point A on the number line? From Salina to Hayes, the same thing as from Hayes to Salina. It's all 90 miles. So what they're saying is, wherever A is at on your number line, x1, right, just some x value, and wherever B is at on your number line, don't they say just subtract those from each other? Correct? And then take the absolute value when it's over with. So let's pretend. Let's do a nice pretending problem. Let's pretend that this was at 3 on the number line, and that was at 8 on the number line. Sound all right? They're asking you, what's the distance from A to B? Well, if you'd follow this, the distance from A to B, sorry, my pen froze, would be absolute value of 3 minus 8. Well, what's the absolute value of 3 minus 8? Well, that's a grouping symbol. What's 3 minus 8? It's not 5. What's 3 minus 8? It's negative 5. But you see how I did what was in the grouping symbols first? Now what's the absolute value of negative 5? It's 5. The distance from A to B is straight up 5, my friends. What if I did it the other way around? What if I did 8 minus 3? Well, the distance from A to B would equal absolute value of 8 minus 3. What's 8 minus 3? So in there is a 5. And what's the absolute value of 5? It's 5, right? Isn't the distance from point A to point B 5 in that situation? Sound cool? And people are always like, well, that's so stupid. Why do we got to do all that work? Why don't we just like take the big one minus the small one all the time and then call it good? What if this was negative 3 and that was, well, let's do a different number. What if that was negative 8 and this is negative 3? We get a little confused when there's negatives involved. So let's use this formula. The distance from A to B should equal, does it matter which one you start with? Negative 3. What am I supposed to do with them? I'm supposed to subtract them from each other, right? What's the other one? It's negative 8, and then they close the bars. But I think you all have been taught what minus a minus is. What's minus a minus? It's a plus. So what's negative 3 plus 8? It's 5. You got the absolute value of 5, which is 5. So you just got to watch when those signs are negative. We use this formula every single time. Cool? Let's do that right here. Use a number line to find each measure. It says find what? What's this ask us to do? Distance from B to D. Let's do it. Where's B at on the number line? What happened here? B's at where? And where's D at? So let's do that. Let's do distance from B to D equals absolute value of negative 7 minus the other one. What's the other one? Minus 1. So I got minus a minus 1, which is really what? Plus 1. Distance from B to D equals absolute value of negative 6, which is how much? Distance from B to D equals 6. I know I didn't give you much room to do that. Sorry. But you know, I always have that person that just wants to ask the question. It's like, why did you go through all that work? Why didn't you just count 1, 2, 3, 4, 5, 6 units apart? Here's why I didn't do that. Because do I care about the right answer? I care about the process. And what if I gave you that B was at negative 1,055 and D was at 271? Would you want to sit there and count all those little tick marks? You don't want to do that. You want to have the process. What is the process to find the distance between those? So let's do that again. Let's skip number 2 so we have room. Let's find the distance from A to F. Let's just go straight to 3. So distance from A to F equals. I'm all about work shown and doing it right. Where's A located at? Negative 9. Then I need to subtract away wherever F is. Where's F located? At 3. Finish that up for me. You should always circle your final answer also. I got the distance from A to F being 12. You feeling pretty good with that? That's pretty simple. Now let's talk about the distance between a pair of points on the graph. Oh, totally different. Would you believe if I found the distance between 2 points on a number line that that's always going to be some sort of horizontal segment? Very simple to find the distance one-dimensionally. This is a number line, correct? Does anybody know what this is really called, this graph right here? The coordinate plane? Undimensional. That's undimensional. Unbelievable that that's a two-dimensional object. Because does it have some length to it? What do you think? Does it have some length to it? That's your x-axis. Does it have some width to it? You bet. That's your y-axis right there. Does it have some height to it? No. That'd be your z-axis if you was to ever graph three-dimensional stuff, which is for another day. But you can graph three-dimensional things also. We have a hard enough time graphing two-dimensional stuff. But this is two-dimensional. It's got an x-coordinate and it's got a y-coordinate. Cool? What's the distance from there to there? I really bet that you'd have a hard time counting what that is. Correct? That'd be a hard time to say, well, I don't know, because that's not straight. So here's the distance formula that we will use. Let's see where it comes from. Here's a made-up example. Okay? Here's 1 point. X sub 1, y sub 1. Are you cool with that? Here's another point. X sub 2, y sub 2. Here's point x1, y1. Here's point x2, y2. If you connected those together, what kind of segment would you get? Horizontal, vertical, or oblique? It would be oblique. You can't just count from here to here and say, well, that's 8 units long, right? So what they did was they do a little thing like this. They say, we want to find the green distance, correct? I want to throw in these other red distances, and you see this shape that shows up is a triangle. And it's more than just a triangle. That's a 90-degree angle, because isn't a horizontal segment and a vertical segment always perpendicular to each other? So this is a right triangle. And have you ever heard of the Pythagorean theorem, to where a squared plus b squared will always equal c squared? Your two legs are a and b, and the hypotenuse is the c, right? It's always all by itself. Well, the weird thing is we just need to figure out how long this is. Cool? Can we figure out where this ordered pair is? Now, I know it's at 2, 2 on the graph. Pretend that wasn't there. But if this is x1, shouldn't this x value still be at x1? You with me? Isn't this point 2, 2, and this point is 2, 6? Weren't the x values the same? So this is at x1. But what's the y value of this green point right here? Isn't it the same as this y value right here? Aren't all these y values the same? It's how much? It's y2. This was the point x1, y2. Sound cool? And what we need is some distances to do the Pythagorean theorem. Well, I want to figure out how long this is. Well, it's the distance horizontally. Isn't this point at 2, 2, and this point is at 2, 6? Isn't that 4 units apart? And how did we get that? We only cared about the x values, which were different. And in general terms, don't we just want to subtract those from each other? So that would be x2 minus x1. Isn't that how long this segment is right here? And this is one side of that right triangle right there. So we need to take it and square it. Right? I want to call this a. That's a squared right there. Sound all right? I need the other leg, which I'll call that b. Well, that's a vertical segment. Aren't the y values different? And wouldn't we subtract those from each other? So a squared plus b squared equals c squared is what I'm trying to do. Correct? So I have a squared already. Now I need plus b squared, and this is b. Isn't that y2 minus y1? And that needs to get squared. So I got b squared right there. And that will equal my hypotenuse squared, which we're still going to call c. Sound cool? All I want to do is get c all by itself. C is being squared. Does anybody know how to get rid of a square? Let's square root both sides. And if I do that, I would get those to cancel each other out. And I'd get the square root of the quantity of x2 minus x1 squared plus y2 minus y1 as a quantity squared. And instead of calling that c, what if I called that point A and that point B? Wouldn't that be the distance from A to B right there? That, my friends, is what this formula is. The distance from A to B equals the square root of x2 minus x sub 1 quantity squared plus y2 minus y1 quantity squared. It's just the Pythagorean theorem to find that distance right there. So, to find the distance between each pair of points, here's what we're going to do on number 9. We'll do this and then we'll go to lunch, okay? So hang with me. First, you always start with what are the names of the 2 points. One of them's A, one of them's B. Don't we want to find the distance from A to B? So we'll start out with this. Distance from A to B equals. Now that's right here in your formula, but this is generic, right? This is just any 2 points. And the next one, when we do R and S, like the distance from R to S, and the next one, the distance from M to N, it's whatever the names of your 2 points are, they go here. Then you put a big old honker radical. Sound all right? And now, if this helps you, I would like you to do this. If you don't need to, you don't need to. But isn't this x1, y1, x2, y2, right? The first one is an ordered pair, x1, y1. The next one is x2, y2. Sound all right? Let's sub them in. It doesn't really matter what order we do them in. I'll explain why, but let's do them in the order that they tell us. x2 minus x1, wouldn't that be 6 minus 0 quantity squared? So far with me? Then the next symbol is a plus. y2 minus y1, 8 minus 0 quantity squared. Sound all right? Cool. And now let's follow the order of operations to clean this up. A radical is a grouping symbol. You must do what's underneath there first. And isn't all of that junk underneath there? Underneath there is some grouping symbols. Don't we need to do what's inside of there first? But we can kind of do 2 things at once. Okay? So bring this down a line. Distance from A to B equals. Let's kill 2 birds with 1 stone. Do you know what 6 minus 0 is? It's 6. Then square it. What do you get? 36. Plus 8 minus 0. 8. Then square it. 64. Sound cool? Then we still have a grouping symbol. We need to do what's underneath there. Distance from A to B will equal. What's 36 plus 64? 100. But has the radical disappeared? That's got to keep coming down. There's people that just decide that that radical can go away and then come back later. Nothing goes away and comes back later. It's never disappeared yet. Square root of 100. Sound cool? Then you got to ask yourself, can this simplify? Can the square root of 100 simplify? What is the square root of 100? Well, it's plus or minus 10, correct? It's plus or minus 10 in an algebra situation. This is a geometry situation. This is the distance from A to B. Can the distance from A to B be negative 10? So it is only positive 10. Sound cool? All right, let's do some more after lunch. The distance from R to S. So we're on number 10 now. And we start with the distance from R to S equals. And then let's do 3 minus minus 2. Oh, 3 minus minus 2. What's that really? 3 plus 2. We got to watch that. That makes a big difference, quantity squared. Then plus, what's in the next one? What do you want to put? 15 minus 3 would work. Would 3 minus 15 work? Because it's getting squared, it's going to give us the same result either which way. Are we okay with that? Let's clean it up now. Distance from RS comes down. Square root symbol comes down. 2 birds with 1 stone. 3 plus 2 is, square it. What do you get? 25. 15 minus 3 is, square it. What do you get? 144. Feeling cozy with that? Next move. We still combine like terms that's underneath that radical. That radical is a grouping symbol, so you still have the square root of 25 plus 144. If you need to punch that in, punch that in. But what is 25 plus a 144? 169. Daddy likes that number. I really like the number 169 because they're asking us to square root 169. Is 169 a perfect square? Sure is. What's the square root of 169? Plus or minus 13, but we got to throw away the minus. Why do we got to throw away the minus? Distance can't be negative. Yes! Set up number 11. Set it up, then we'll do it together. Set it up. Set it up. And then check yourself with what I got. Doesn't have to be exactly the same, but you must have it in general principle. Cool? So distance from M to N equals 2 birds with 1 stone. 9 minus 1 is 8. Square it and get 64. Even if you did 1 minus 9, wouldn't you get negative 8? And then that would be squared, you get positive 64. So it's all good. That's 13 plus 2, which is 15. Squared is 225. All righty? And now we need to add those together. 64 plus 225. 289. Are we okay with what we have so far? Well, let's check. Is 289 a perfect square? 289 is a perfect square when you punch it in, so this is from M to N equals 17. Timeout. We've done 1, 2, 3 problems so far. They all came out to be whole numbers. Everything was perfect square. Do you think they will always be like that? No. So let's try again. Let's find the distance from E to F. Distance from E to F. Set it up. Big old honker radical. Watch your signs. Then go one step further and stop and look to see if you got the right numbers in the right place. You should have got a 9 and a 16 come out of that situation, right? And then what is 9 plus 16? How much is it? Pretty sure it's 25. 25. And again, we get a nice, neat, perfect square. So square root of 25, which is plus or minus 5, but we got to throw away the negative. Sound okay? That it for the distance formulas here? Yes. Let's pretend we got another answer. What if we went through the whole distance formula and it turned out to be the square root of 24? Is 24 a perfect square? So our job is to simplify that radical. Find a list of perfect squares. And isn't 25 actually too big? So let's work backwards. Does 16 go into 24 evenly? What do you think? Nope. Does 9 go into 24 evenly? Does 4 go into 24 evenly? So this would get broken up into 2 radicals. What goes here? 4, because that's the perfect square. How many times does it go in there? And that turns into 2 square roots of 6. If it doesn't come out to be a nice perfect square underneath the radical, see if you can simplify the radical. Sound all right? Square root of 39. So 25, then the next one's 36, the next one's 49. 49 is too big. Does 36 go into 39 evenly? Does 25? Does 16? Does 9? 9 go into 39? Does 4? 1 goes into everything. 1 doesn't count. That's as simplified as it gets right there, square root of 39. So not every radical can simplify either. Sound cute? To the back side. Midpoint. Midpoint. M. Notice what kind of letter M is. What kind of letter is that? So that's point M. Right? I just say it out loud as M anymore, but M is the midpoint of, what does that say? Segment AB. M is the midpoint of segment AB. If and only if. M is the midpoint of segment AB. If and only if. Point M is on segment AB. If and only if M is on segment AB. And, whoa, my friends, I need some help reading that out loud. What the heck does that say? Distance from A to M is equal to the distance from M to B. If you know how to read it, you will be so much more successful. Right? Instead of saying M is the midpoint of AB, if and only if M is on AB and AM equal MB. That means nothing. Right? Read it mathematically. Sound cool? Let's draw a picture. Get yourself a straight edge, and let's draw a nice picture. We first need segment AB. So draw segment AB for me. A and B are the endpoints. Correct? I want to put M in this picture. M is our midpoint. Where should M be located according to this definition of midpoint? Right in the middle. So what about right there? Right in the middle. Oh, it's got to be where? On segment AB. So first of all, that doesn't even fly, correct? So right there. What do you think about that? Is it on it? Satisfied, right? Right here. It's on segment AB. Satisfied. Now, is that good enough? I also must satisfy this. The distance from A to M must be the same as the distance from M to B. Correct? How do I satisfy that? I need these two to be the same. They said measure it. I don't need to be accurate enough to break out a ruler and measure it. There's one way mathematically to say that the distance from A to M should be the same as the distance from M to B is to do what? Put the tick marks on it. Boom, boom. Now you know for sure that the distance from A to M is equal to M to B, because that's what the tick marks mean. Sound cool? It's all about the tick marks. Two things. M's on there, and the distance from A to M is equal to the distance from M to B. What if I had this? What do you think about that? Two tick marks and one tick mark means different things. What if I had that? Would that be the same? Two tick marks and two tick marks means that they're the same right there. Cool. What if I drew this? A, B, M, tick, tick. What do you think about that? Is M the midpoint of segment AB? Not at all. Why isn't it? Here's segment AB right there. That blue thing is segment AB. Is M on it? No, right? It's got to be on there, and then the distance from A to M has to be equal. All that happened in this picture was the distance from A to M is equal to the distance from M to B, but M's not on segment AB. You with me on that? So that's called equidistant right there. They're equal distances, but it's not the midpoint. Cool? It's very tricky. So we've got two different situations here. To find the midpoint on a number line, we're going to use this formula right here. Excuse me, the points on your number line, one of them is an X, another one's an X. There's just two different ones, right? Here's what they say. They say add them up, correct? And then divide by how much? What happens when you add two things, then divide by 2? What are you really finding? First test score, 100%. Second test score, 90%. I add them up. then divide by 2 and give you the number 95. What did I just give you? Your average, correct? Aren't I averaging these, right? When you add 2 things up, then divide by 2, that's average. If you add 3 things up, then divide by 3, you're still averaging them, correct? So we're just finding an average on a number line. So here we go. Let's do these exercises. Use the number line to find the coordinate of the midpoint of each segment. Segment CE. Well, where's C at? So I need a -4. I need to add it to wherever E is. E is located at where? 2. Then I need to divide it by 2. Notice I'm showing a little bit of work. I just don't care about your answer. I care about just a little bit of setup. What'd you do? Here's C, -4. Here's E at 2. Didn't I add them together? And I want to divide them by 2. Remember, a fraction bar is a grouping symbol. You must do what's in the numerator first. -4 plus 2 is how much? -2. It's still over 2. What's -2 over 2? The midpoint is at -1 on the number line. Let me show you. You don't have to do this, but let me show you. Here's -1 on the number line, right here. And that is smack dab in the middle between C and E. The green thing is exactly the same distance as the blue thing right there. -1 is where the midpoint of segment CE is on that number line. Sound okay? Let's do 15. Let's jump over to the segment AF. So set it up for me. Where's A? Where's F? Add them together. Put them over 2. Right? -9 plus 3 all over 2. Sound cool? Now are our algebra skills good enough to do this? What's -9 plus 3? Divided by 2. If they're not good enough, go one more step, right? Simplify and then simplify again, right? But if you could skip that little step, go for it. Let's make one up. Let's find segment BC. I would like to do a different problem. Don't want to do that. Let's find the midpoint of where segment BC would be. Cool? So let's set it up. Where's B? Correct. Plus C. Where's C at? Now let's not be immature math people and write plus -4. What does that really turn into? -4, right? And it's got to be over 2. Sound all right? Numerator. -7 minus 4 is how much? Does that come out nice? Or will that be a decimal? That will be a decimal. So that means you will not punch that in. That's the coordinate of the midpoint, -11/2. If it doesn't come out to be an even number, like an integer, then there it is, -11/2. Sound okay? That's midpoint on a number line. Now, they give you midpoint on a coordinate plane. Like here's point AB, it's graphed. Here's point A, here's point B. We want to use this formula. I will have this formula provided for you all the time, this midpoint formula. It looks really, really complicated. But I want to draw you a little sketch. Okay? Would you believe if I called this A and this B, and M was truly the midpoint of it, right? And we're on some sort of graph, if that's going on, right? That A is an endpoint and B is an endpoint of those segments, correct? And M is the actual midpoint, correct? Well, what you'll have is when you're on the coordinate graph is this will be some ordered pair, let's say like 2, 3. This will be some ordered pair like 5, 11 or something like that. Then you got to figure out where this is. Won't it have an x value and a y value also? That's what this formula is all about. It says, here's what you'll do. You got 2 situations. It's almost like this should be in parentheses. Here's your x value, underlined in green. Here's your y value, like an ordered pair, x, comma, y. You with me? To find the x value, here's what's going on. You take the endpoint of one of yours, one x endpoint, plus the other x endpoint and divide it by 2. And that will equal the x value of your midpoint. To do the y's, you do the same thing, but let's kind of set it up as we go. Let's read the instructions, though, to see what they're wanting. They say, find the coordinate of the midpoint of a segment with the given endpoints. What did they give us? Did they give me both endpoints, or did they give me a midpoint and an endpoint? Because that's what they're going to do down here. They're going to give you a midpoint and an endpoint and ask you where the other endpoint would be. So you have to be very, very careful. What did they give me in these three problems? Both endpoints or midpoint and endpoint? They gave me both endpoints. You with me? This is the easy situation. So let's set it up like this. It's going to be an ordered pair. Let's do our x's first right here. This says add your two x value endpoints together. Isn't A an endpoint and B an endpoint, right? What are the x values? 0 and 12. Add them together. Don't skip steps, right? Show me some work and put it over 2. That's all my x information right there. I just did all of that in green, right? That's my two x value endpoints. All is divided by 2. To do the y value, you do the same thing, but with the y value numbers. Isn't this 0 and 8? We're supposed to add them together and divide by 2. And that will be the ordered pair once we get it all cleaned up. Let's clean it up. What's 0 plus 12? Divided by 2. What do you get? 6. And then you figure out the y value. What you got? 4. If I had point AB on the graph, right? A is at 0, 0, B is at 12, 8. The midpoint would be at 6, 4. Let's do that again. Don't they give me both endpoints right here? Let's find the midpoint. So I'm going to set it up as an ordered pair. X's first. Add the x values together and divide by 2. Then for y's, add the y values together and divide by 2. I'm setting it up as an ordered pair. It just hasn't been simplified yet. Cool? All you got to do is clean that up. Simplify it. What's negative 12 plus 6? Negative 6 divided by 2. And then the green one would be 20 over 2, right? 20 over 2, which is really how much? 10. Cool? Why don't you and your partner get number 19 done? So pause the video, get that done. Hopefully we got 11 halves when we did that. Now, here's the messed up part. Find the coordinates of the missing endpoint, right? An endpoint is missing. Cool? What did they give me? They gave me a midpoint and an endpoint. So we have to see which one's which, right? We got to see which one's which. First of all, we got to use their names. They say find the coordinate of the missing endpoint if B is the midpoint of segment AC, right? They gave me 2 points there, C and B. Which one of those is the midpoint? B. They straight up told me that, right? Didn't they say B was the midpoint? So let's do this as mid, and this is end. Cool. C is an endpoint. B was the midpoint. Sound cool? We need to find where A is located, because it was segment AC. So we've got 2 different situations. We're not going to write it as ordered pairs. Let's use this situation first to find the x value of that missing endpoint. Doesn't this say x end 1 plus x end 2 over 2 equals x mid? Right? Here's the x value of the midpoint right here. Do you know it? What is it? It's negative 2. Isn't this the x value of the midpoint? This is the x value of one of the endpoints. Do you know one of the x value of one of the endpoints? It's negative 5. Do you know the other x value of one of the endpoints? So let's do this. Let's just call it negative 5 plus x over 2 equals negative 2. Now let's see where that came from. Right? And let's realize that this is all of, oh, we got an x in there. We got an x in there. We're trying to find the x value of our endpoint. We had the x value of the midpoint. Doesn't that go right here? We had the x value of the endpoint. It went right here. We just didn't know the other one. Correct? And we put it over 2 because that's what the formula says. Like I said, this formula will be on your cheat sheet and all that stuff for you. Let's solve for x. What's the first move you would do to solve for x? Multiply both sides by 2. Here's a question for you. I would like to see what you know. How many terms are in this guy? Let me refresh your memory where terms are. Terms are separated by addition signs, subtraction signs, and equal signs. What do you think? There are only 2 terms in there. The reason why is because we've got something that trumps it. I see that addition sign in there, but isn't that in a group? Isn't this a grouping symbol? And you always take a blind eye to what's up there. Who cares what it is? Isn't it something over 2 and a negative 2 right there? There are only 2 terms in this equation right here. So when we want to get rid of that divide by 2, we want to multiply every term times 2. What does this times 2 and that divide by 2 do to each other? Cancel. And this comes down, negative 5 plus x. Equals comes down. We still have to take 2 times negative 2, and that becomes a negative 4. But this was just up there in a group, right? It's got to come along for the ride. Very, very tricky. Solve for x. Y's. So we found x to be 1. Now it's time to find the y's. So I think you have some room down below that, right? Let's keep working below. But let's set it up with the y values. Start with the y value of the endpoint, which is what? 4 plus, what variable should you use right here? Use a y over 2, and that will equal the y value of the endpoint, which is, are you guys okay with that setup of where that all came from? Cool? Solve for y. Pause the video, get that done. So we should get y equals 6, but we're not finished. They want us to find the coordinate of the missing endpoint. We need to write it as an ordered pair. And what's the name of this point? We got B already. B's at negative 2, 5. We wanted to say, we knew that B was the midpoint of segment AC. How many points are involved in all of this information? We got A, we got C, and we got B, correct? Do we know where A is? Nope. Do we know where B is? Yep. Do we know where C is? So that means this one was which point? So we'll say A is at 1, 6. That's how you say point A is represented at 1, 6. Because the x value was 1 and the y value was 6. Correct? Let's jump over to 22 and make that our last one. Same set of instructions. First thing you should do is this. This really, really helps. Identify what the endpoint is and what the midpoint is. Which one of those is the midpoint? So put mid above there and put end above this one. That will help you in your setup. Right? The more you can label stuff, the easier it is to do it. So start by finding the x value of the other endpoint, and then we'll move on and find the y value. So pause the video and get that done. And this is what you should